Hello, dear students. Once again, welcome to this YouTube channel. So today we have to discuss about circular motion. So in previous topics, that is motion in a plane, we have already discussed uniform circular motion, and we got the expression for centripetal acceleration. So that is a body which is moving or revolving around the circumference of a circle, then with constant speed, but it has acceleration and it is accelerating towards the center. Okay, and the acceleration towards the center, that is centripetal acceleration, as A equal to v square divided by r, where v is the uniform circular speed, and r is the radius of the circular path. Okay, so let us to discuss this circular motion. Okay, and according to the second law of motion, the force F providing this acceleration is force, that is force F equal to mass into acceleration. That acceleration is v square divided by r. So therefore we can write that force towards the center is mv square divided by r, and where m is mass of the body and this force directed towards the center is called centripetal force. Okay, simply centripetal force means mass into centripetal acceleration, remember. Okay, force equal to mass into acceleration, and acceleration towards the center is called as the centripetal acceleration, and mass into centripetal acceleration is centripetal force. So the expression for the centripetal force is mv square divided by r. mv square divided by r. Okay. See, for example, a stone is rotated in a circle by a string. The centripetal force is provided by the tension. The centripetal force is provided by the tension in the string. Next, the centripetal force for motion of a plane around the sun is the gravitational force on the planet due to the sun. Cleared? And also the motion of the satellite around the planet. Okay, so these are the some examples we can see circular motion, and in that the centripetal force, that is mv square by r, and this force is provided by gravitational force. Next term is impulse. Impulse means, see, suppose a large force acting for a short duration or short interval of time, producing a finite change in momentum. This producing a finite change in momentum of the body. Here the force and the time duration are difficult to measure, okay, separately, because that force acts very short interval of time. However, the product of force and time, which is change in momentum of the body, and this force into time is impulse. Force into time is impulse or impulsive force. So impulsive force means simply force into time. Force into time. And also we can measure this impulse as change in momentum. Change in momentum, remember. For example, when a ball hits a wall and bounces back, the force on the ball by the wall acts for a very short time. When the two are in contact, means the contact time is very, very small. Okay, but the force is large, and that force is enough to reverse the momentum of the ball. Okay, so impulse of force, that is the product of the force and the time, is called impulse of a force. Impulse of a force means force into time, F into t. See, force means rate of change of momentum, that is force equal to change in momentum by time. Change in momentum by time. Cleared? So F into t, force into time, is impulse, and also we can write change in momentum. Impulse equal to force into time, duration, or change in momentum. Change in momentum gives impulse. Cleared? Okay. See, so this simply, the impulse means large force acting for a short time to produce a finite change in momentum is called impulsive force, and this impulsive force is measured in terms of force and time, that is force into time, or simply change in momentum. Change in momentum. Okay, and also you can take one more example, hammering a nail into a wall, hitting a ball by a bat, okay, are the examples. Then what about the SI unit of impulsive force? Force unit is Newton, time unit is second, so Newton second. Okay, and also change in momentum, the dimension of the change in momentum is same as the dimension of momentum, and momentum is mass into velocity, that is the unit of momentum is kg meter per second. Mass into velocity, kg meter per second, that is change in momentum. Okay, or Newton second, force into time, Newton second, or kg meter per second. Okay, so these are the units of impulse. Okay, so now by knowing about this impulsive force, one more common force that can arise in the motion, that is friction. See, ಈಗ ನೋಡಿ ಏನಿದು ಫ್ರಿಕ್ಷನ್. ಓಕೆ, ಫ್ರಿಕ್ಷನ್ ಅಂದರೆ ಏನು? ಈಗ ಒಂದು ಬಾಲನ್ನು ನೀವೇನು ಮಾಡ್ತೀರಿ, ಒಂದು ಗ್ರೌಂಡ್ದಲ್ಲಿ ಉಳಿಸ್ಬಿಡ್ತೀರಿ, ಉಳ್ತಾ ಹೋಗ್ತಾ ಇರುತ್ತೆ. ಬಟ್ ಏನಾಗತ್ತೆ, ದ್ಯಾಟ್ ವಿಲ್ ಕಮ್ಸ್ ಟು ರೆಸ್ಟ್ ಆಫ್ಟರ್ ಟ್ರಾವೆಲಿಂಗ್ ಸಮ್ ಸರ್ಟನ್ ಡಿಸ್ಟೆನ್ಸ್. ಒಂದು ಇಂತಿಷ್ಟು ದೂರ ಹೋದ ನಂತರ ತನ್ನಿಂದ ತಾನೇ ನಿಂತು ಬಿಡತ್ತೆ. ಅದೇ ರೀತಿ ಒಂದು ಪ್ಲೇನ್ ಗ್ರೌಂಡ್ ಮೇಲ್ಗಡೆ ಅಥವಾ ಒಂದು ಪ್ಲೇನ್ ರೋಡ್ ಇದೆ ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ. ಅಲ್ಲಿ ಆಲ್ರೆಡಿ ನೀವು ಸೈಕಲ್ ಪ್ಯಾಡ್ಲಿಂಗ್ ಮಾಡಿದಿರಿ, ಸೈಕಲ್ ಓಡ್ತಾ ಇದೆ. ಪ್ಯಾಡ್ಲಿಂಗ್ ಮಾಡೋದನ್ನು ಸ್ಟಾಪ್ ಮಾಡಿಬಿಡಿ, ಸೈಕಲಲ್ಲೇ ನಿಂತು ಬಿಡೋದಿಲ್ಲ. ಅರ್ಥ ಆಯ್ತಾ? ಸೈಕಲ್ ಚಲಿಸ್ತಾ ಇರುತ್ತೆ. ಬಟ್ ಏನಾಗತ್ತೆ, ಇಂತಿಷ್ಟು ದೂರ ಹೋದ ನಂತರ ಸ್ಪೀಡು ಕಡಿಮೆ ಆಗ್ತಾ 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 ಹೋಗಿ ಅವಾಗ ಸ್ಟಾಪ್ ಆಗತ್ತೆ. ಹಾಗಾದರೆ ಈ ಮೂವಿಂಗ್ ಆಬ್ಜೆಕ್ಟು ನಾವು ಯಾವುದೇ ರೀತಿ ಫೋರ್ಸ್ ಹಾಕದೆ ಸ್ಟಾಪ್ ಆಗ್ತಾ ಇದೆ. ಹೌ ಇಟ್ ಈಸ್ ಪಾಸಿಬಲ್? ಏನಾಗಿರುತ್ತೆ ಅಂದರೆ, ಇಲ್ಲಿ ಆ ಒಂದು ಮೋಷನ್ಗೆ ಒಂದು ಫೋರ್ಸು ಅಪೋಸ್ ಮಾಡ್ತಾ ಇರುತ್ತೆ. ಆ ಫೋರ್ಸು ಎರಡು ಸರ್ಫೇಸು ಕಾಂಟ್ಯಾಕ್ಟ್ ಇದ್ದಾಗ ಅಲ್ಲಿ ಆ್ಯಕ್ಟ್ ಆಗ್ತಾ ಇರುತ್ತೆ. ದ್ಯಾಟ್ ಒನ್ ಇಸ್ ಕಾಲ್ಡ್ ಆ್ಯಸ್ ಫ್ರಿಕ್ಷನ್ ಆರ್ ಫ್ರಿಕ್ಷನಲ್ ಫೋರ್ಸ್. ಆ್ಯಂಡ್ more about this frictional force we can discuss in the next video. Okay, this frictional force arise due to the relative motion between two surfaces. ಎರಡು ಸರ್ಫೇಸು ಒಂದಕ್ಕೊಂದು ರಿಲೇಟಿವ್ ಮೋಷನ್ ಆಗಿದ್ದರೆ ಅಲ್ಲಿ ಒಂದು ಫೋರ್ಸ್ ಬರುತ್ತೆ, ಅಪೋಸಿಂಗ್ ಫೋರ್ಸ್ ಬರುತ್ತೆ. ಅದೇ ಫ್ರಿಕ್ಷನಲ್ ಫೋರ್ಸ್. ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು.